Today we will do the class example 20. For some sections I completed that, and for some sections I couldn't complete that. So I'm doing this class example from the very beginning so that you can see and do your homework. So the question was, the wing on the aircraft in figure 8.3 is subjected to a drag Fd created by the airflow over its surface. It is anticipated that this force is a function of the density, viscosity of the air, the characteristics length L of the wing, and the velocity V of the approaching flow. Show how the drag force depends on these variables. So this is the very first example we used to explain what is dimensional analysis. So we will do the actual calculation right now. So it has few steps. You can find those in your lecture copy. The step one is define the physical variables, determine the number of variables and number of primary dimension. Okay, so the physical variable, that will be drag. The very first one will be drag force Fd. The next one will be density rho. Next one will be viscosity, kinematic viscosity. Oh, sorry, it will be the dynamic viscosity. Length L, and the velocity. Okay. And for each variables, we will get the dimension from table 8.1 because we need that for the primary dimension. So if I look at the table 8.1, here, this one, this table 8.1. So for the very first one, drag force, like which is a force here, we will use the FLT method. So this is just F. And you can find all the other variables here as well. So I will move to the problem here. So this one is just F. For density, it's F T square L to the power 4. For viscosity, it's F T L T square. It's L, and this one is LT1. Okay. Now, number of variables, we have 1, 2, 3, 4, 5. And number of primary dimension, this one is n. M. So let's see how many primary dimensions we have. We have F, that is 1. We have T, that is 2. We have L. So we have F, L, and T. So that means we have 3 primary dimension. Okay. And so we can move to the step 2. Select the repeating variables and determine how many terms you will have in your analysis. Okay, so the repeating variables, as I said, for each pi term, there will be some variables. You will have those variables in every pi terms, and that's why it's called the repeating variable. To choose the repeating variables, we need to consider some thing. So we will do that. So the very first one is how many repeating variables we will have. So number of repeating variables equals to number of primary dimension. So number of repeating variables will be M, which is 3. Okay, that is good. Now we know how many repeating variables we will have. Now for B, collection of the dimensions should contain all the independent dimensions. Okay, so here we have 5 physical variables. Among these 5, we need to choose 3 repeating variables. so that the collection of primary dimension will contain F, L, and T. Okay. Now, since the question is asking the drag force is a function of all of these, so let's keep F out of these repeating variables, because that will be like F equals to something. So out of these four, we can choose any three, so that we will have F, L, T altogether. We can choose any three, as I said. So for this problem, I will just choose maybe rho, L, and V. I could choose in other way also, like rho, viscosity, length, or viscosity, L, length, velocity. In any combination, I will have F, L, T, but I will just choose these three. There is no specific reason I chose that. But if you look at L and V, you see their expression, their dimension is a little bit less. So you will just have L1 and L2, which is 2. So that will help us with the calculation. Other than that, there is no other specific advantage of choosing these three. Okay, so collection of their dimensions should contain all the independent dimensions. So we are choosing rho, L, and okay, and number of pi terms equals to n minus m. So n was 5, m was 3. So we have two numbers. We will have two pi terms. Okay, so that is step 2. Step 3, pi terms. Select one term to be q and multiply it by all the m repeating variables. Okay, so since we have two pi terms, we will have pi 1, pi 2, okay? And we have FD and the viscosity, which are not the repeating variable. They are not the repeating variables. So they are actually Q terms. Okay. So how I will write down pi 1 and pi 2? It will be repeating variables times Q, and there will be exponent xy here again. One, two. Okay. So for pi 1, I will use, we have rho A, LB, VC, and FD1. For pi 2, I will have rho D, LE, VF, and the viscosity 2. Okay. So these are my pi 1 and pi terms. So what we will do in next slide, I will use that pi 1, A, L, B, V, C, F, D, 1. So for rho, we had F, T2, L to the power 3, A, we have LB, we have L, T minus 1, C, and F1, okay? And we also know this, since this is pi 1 pi, this is non-dimensional, so it's actually 1. And you know that anything to the power 0 is actually 1. So we can say F0, L0, T0 equals to 1 for this part. Okay. So we can write down similarly for pi 2, rho D, L, E, V, F, and viscosity. And we can say F, square L3 D LE LT1 F, and for the viscosity it was F T L minus 2. Okay, and this one is 1. So is 1, you can say F0 T0 L0. This one you can say F, I should use the different color. Maybe this one, and say F0 L0 T0. Okay, so that is step 3. Now we will work with step 4. So what we will do, we will just try to find what will be the ABC value and DEF value. So here I will work with pi 1 first. Okay, so pi 1 was, I will just write down again. It was if A T2A L4A, because FTL to the power 4A, LB LC T minus C and F. Okay, and I can write down that for this one it was F0 T0 L0. Okay, so for F0 equals to, for T 0 equals to, for L 0 equals to. Now we will identify what are the values on this side. For F, we have one F here and here. So this one is easy, A plus 1, okay? Because the power here, it was 1. For T, we have this one, okay? And do we have anything else? No, okay. So we have 2A minus C, okay? And for L, we have this one, this one, this one. So we have negative 4A plus B plus C. Now you see, I chose L and V because we had less amount of dimensions there, and that is actually helping with these two equations. We don't have too many things here. So from here, it's very easy. It's 3 equations, 3 unknowns. So A equals to -1. And here you can use A value to find the C value, which is -2, negative C equals to 0. That means C equals to -2 here, right? And if you use all the values here, suppose 0 equals to -4, 1. We don't know the B value, but we know the C value equals to 0. So this one is 4 plus B minus 2. So B is actually -2. Okay. So our final pi term is pi 1 if A is -1, which is, or sorry, rho A. So it was rho A L B V C F. That means we have rho -1, L -2, V -2, and FT. Right? Okay. And you can arrange that in that way, that FD over rho L square V square. Okay, that is pi 1. Now we will work with pi two, which one was rho L V F and viscosity. So we had F0, L0, T0, and for this one, if we get all the values from step 3, it was FD, T to D, L for D. For L, it was just LE. For F, it was L, F, L, F, T minus F, and for viscosity, that viscosity it was F, T, L minus 2. Okay, so for F, 0 equals to, for L, 0 equals to, for T, 0 equals to, now we will identify. The first one is 0, F, F. So this one is D plus 1, which directly give you this one. For L, we have 0, this one, this one, this one, and this one. So we have negative 4D E plus F plus 1. Okay. Now the very last one, which is T 0 to D, this one, this one. So that means 2D negative F, and here the very first one was okay, I think I wrote just the opposite thing here. Sorry guys, these will be, these two are just opposite. It will be F T L to the power 2. Okay, so when we work with L, that should be 2, negative 2. That's not, so that is negative 2. And now when we are working with L, T, this is the 1, so F plus 1. Okay, now if you solve these, you should get D equals to negative 1, E equals to negative 1, and H equals to negative 1. So basically you have pi 2, rho negative 1, L negative 1, V negative 1, and viscosity. So that simply gives you viscosity rho L V. And if you look at that dimensionless number, that is actually the Reynolds number. Okay, so finally we can say that the drag force is a function of that pi 1 and pi 2, and these are just the pi 1 and pi terms expression. So FD, the very first one, and this one is Reynolds number. Okay. So we started with 5, but now we have just 2 non-dimensional number, and when we do the experiment, instead of 5, you can just choose different number of pi 1 and pi 2. And one good checkpoint each pi term should be dimensionless. Okay, that is the important checkpoint. Now, instead of FD over rho L square V square, you can get like pi1 equals to rho L square V square over FD. That doesn't matter. If you check that, it will be again dimensionless number. So this is the checkpoint. If you get any pi1, any pi terms which is not non-dimensional, there is something wrong. Okay, class. So that's the end of class example 20.